All right, polynomial division. We have two ways to divide polynomials. You've done both of these in Algebra 2. We have long division and we have synthetic division. Okay, so today is a reminder of how to do those. And what do they tell us about our polynomial? So first, let's remember how to do long division of polynomials. It'll come back to you. All right? So we have this fourth degree polynomial divided by a second degree polynomial. All right? So we're going to say 2x to the fourth plus 4x cubed minus 5x squared plus 3x minus 2. And we're dividing that by x squared plus 2x minus 3. Okay? All right, so what you do, you look at your first terms. You look at x squared and you look at 2x to the fourth. And you say x squared times what is 2x to the fourth? 2x squared. That's what goes up here. 2x squared times x squared gives us 2x to the fourth. Notice how I'm organizing by columns. If I write anything x squared, it's going to be in this column. Right? Now what do we do with this 2x squared? We have to multiply it by this, what we call our divisor. Okay, so we have x squared times 2x squared. We have 2x times 2x squared. Okay. And we have negative 3 times 2x squared. Okay. Now, what do we do with what I just wrote in red? We subtract it. This is what I'm going to tell you. Don't do the subtraction right here. Carry the subtraction through, otherwise you're going to forget. So subtract, subtract, subtract. Okay? This first set of terms should always cancel. That was the whole point of picking that 2x squared. What about 4x cubed minus 4x cubed? That conveniently goes away. And we're left with what right here? X squared. Then what do we have to do? We need to bring down the negative 3x. Since I have 3 terms in my divisor, I need to have 3 terms down here to work with. So I'm going to go ahead and bring... Thank you. So I'm going to go ahead and bring down both of them. However many terms in my divisor need to match this because we're going to have to do some subtraction. Right? Okay, now, same process. X squared times what is x squared? So I'm going to put plus 1. All right? So we have x squared times 1, 2x times 1, negative 3 times 1. And what are we doing there? We are subtracting. So subtract, subtract, subtract. Okay? What are we left with? X plus 1. Alright? Now notice, my divisor is x squared. That cannot divide into x plus 1. So x plus 1 we call our remainder. So how do we write our answer? 2x squared plus 1. And what do we do with our remainder? Put it over our divisor. Yay! Coming back?
I remember doing that all.
I don't think
Ever.
people ever like
Can we
might
do
have
another
one
one?
of those with us, but then he just went straight to synthetic. So
Yeah, so we used to use synthetic like all the time.
Okay, now, here's the thing. Synthetic can only be used in certain situations. Synthetic division can only be used if your divisor is linear. So if your divisor is not linear, like here, you have to do long divisions. You have to know how to do this, okay? All right, I'm throwing around words like divisor, dividend, blah, blah, blah. Which ones are which?
Divisor's the one on the outside.
This is divisor. Look, what's this? Dividend. This is the quotient. And then here's our remainder. Okay? Why am I throwing out these words? Okay? The division algorithm. This is what I would write right here. This is the division algorithm. This means that our dividends equals the divisor times the quotient plus the remainder. Okay, write it down. You'll need it for your homework assignment, and then we'll talk about why it is true.
at the end of the hour.
Okay, so I am going to show you what this means using numbers. Just a simple division with numbers instead of polynomials, okay? That way you can see why this is true, okay? So if I take 10 divided by 3, what is 10? Our dividend. What's 3? Our divisor, okay? What is our quotient? How many times does 3 go into 10? 3. With a remainder of 1, right? Okay. So what this means is we have 10 divided by 3. That equals 3 plus our remainder of 1, which we always put over the divisor, right? Okay, so what happens if I were to multiply everything by 3? I would have 10 equals 3 times 3 plus 1. Our dividend equals our divisor times the quotient plus 1, our remainder. Okay, so this is what this division algorithm means. Okay, it's just making it so we don't have any questions. Okay, so you will be asked in your homework to write something like this. Okay, now I need to show you when we need to be careful. Okay, we're going to do long division again because I know you need to practice. Okay, but why am I saying you're going to need to be careful with this one? Okay, look at our dividend, x cubed minus 1. We're missing some terms, aren't we? What do you have to do if you're missing terms? You need to put something in their place. So we have x cubed plus 0x squared plus 0x minus 1. And we're dividing by x minus 1. If you do not put those zeros there, okay, it will mess up your division, whether you're doing long division or synthetic division. Okay, here you won't have any room to do any of your subtractions. Alright? So, we always start out with our first terms. X times what is x cubed? X squared. Okay? So then x times x squared is x cubed. Negative 1 times x squared is negative x squared. And what are we doing here? Subtraction. So carry the subtraction through your entire line there. Right? So what are we left with? X squared. And then we need to bring down a 0x. My divisor has 2 terms. So I need to have 2 terms. Okay. So now we look at the first terms again. X times what is x squared? X. X times x is x squared. Negative 1 times x is negative x. And we need to subtract. Okay. So what are we left with? Positive x. And we'll bring down minus 1. Hey, this is nice. X times what is x? 1. What happens when we take 1 times our divisor? We get x minus 1, which means our remainder is 0. It divides evenly. Okay. Okay, so what can we say about x minus 1 if it divides evenly? A factor. I like where you were going with that, but we call it a factor. Okay, so x minus 1 is a factor because it divided evenly. Okay, and what do factors tell us? What can we get from factors?
Zeros.
Ah, we get zeros. Okay. Let's talk about synthetic division, your favorite. You love synthetic division compared to long division. However, we can only use it if we have a linear divisor. That is the only time it works, when you have a linear divisor. Okay? So we have our linear divisor of x plus 3. Notice how this is in the form x minus k, kind of like our factors. Okay? So if we have x plus 3, what number goes outside here? What? Minus 3. Okay? We don't have to worry about any x's, right? X plus 3 is our divisor, so negative 3 is out here. All right? Now, we just need to take these coefficients and list them out here. Are we missing any terms? You always need to look first if you're missing any terms. We are. We have 1x to the 4th plus 0x cubed minus 10x squared minus 2x plus 4. Okay? And we know whatever we get down here in our last column, that is going to be our remainder. Right? Okay, so walk me through the process. What do we do first? Okay, we have to bring this one down. And what do we do with this one? Multiply it by negative 3. What do we do with the column? We add. Same process. We take this number, we multiply it by negative 3. What do we do with the column? Add. Negative 1 times negative 3. We add to get 1. 1 times negative 3. we add to get 1. Okay? Now, this gives us our quotient with our remainder. We took a 4th degree polynomial and we divided it by a 1st degree polynomial. So our quotient is going to be what? A 3rd degree polynomial. So this means x cubed minus 3x squared minus x plus 1, and then plus our remainder over our divisor. Did you have a question?
Oh no, I just
Okay.
had a lot easier than the other one. We always had to do long division.
Why did you bring the -3?
This negative 3 I got from this x plus 3. You said this equal to 0. Okay? Alright, now the remainder tells us a few different things. Okay? First thing that it tells us is that, okay, if we have a polynomial that we divide by a linear factor, okay, so if we do synthetic division, then the remainder is the function evaluated there. What does that mean? Okay, let's read this. If I have a polynomial f of x, I divide it by x minus k, then the remainder is f evaluated at k. Okay, write it down and we'll talk about that, what that means with our previous example. This is the example we just did on the previous slide, correct? What was our remainder? Our remainder was 1. So what this means is f evaluated at -3 is our remainder 1. When we do synthetic division, the remainder gives us the function value here. So instead of plugging -3 into each of these and doing all of that multiplication, we can do synthetic division and our remainder is that function value. Does that make sense? Okay. If I told you to find f of -3, what would you do? You would plug -3 into all of these, right? Okay. Synthetic division with -3 right here, whatever our remainder is that same thing. Instead of plugging -3 into all my x's, the remainder after synthetic division gives us that same thing. Okay? In some cases it could be quicker, some cases maybe not.
Wait, so like if you were to plug in -3 for all the x spots, and then whatever that equals, it would be the same as doing the synthetic division thing.
Yes. Yes. Okay. Now, what would happen if this were to be 0? What if my remainder is 0? What does that mean? It divides evenly, okay? If something that divides evenly, we can say, just like we did before, that it is a factor. Okay? For example, we're going to take 2x cubed plus 4x squared plus 3x plus 1, and we're going to divide it by x plus 1. Okay? So how do we do our synthetic division? What goes on the outside? -1 goes on the outside, right? And we have 2, 4, 3, 1. We bring the 2 down, 2 times -1, we add our column, 2 times -1, we add our column, 1 times -1 is 0 when we add our column. I put a happy face in my 0, okay? Why? Well, we divided evenly, so what do we call x plus 1? Huh? A factor. Okay. And what would we be left with? What are we left with here? Okay. So we know x plus 1 is a factor, which also means what? If we have a factor, what can we find? A 0.
Wait, it's a factor of the first one?
It's a factor of this. Okay, what?
I'm really excited about it.
Oh, because we can do so much of this. Okay. Okay, so first of all, the remainder gives us the function value, right? In this case, 0. If our remainder is 0, then we have a factor. If we have a factor, we know 0. Okay. This will be important next week when we do, when we start to find zeros using synthetic division. Okay. So the remainder is our function value. If it's 0, then we have a factor which gives us a 0. Now, if I told you that x plus 1 was a factor, like that was a fact, that x plus 1 was a factor, okay, then we would know we should get a 0 here, right? So if I tell you that x plus 1 is a factor, we should get a 0. If I want all of the zeros after that, what would I have to do with this quotient right here? Well, we have a quadratic. We know how to solve quadratics, don't we? We can either try to factor it, or we can use our lovely quadratic formula. Okay? So you may get a problem where it says, hey, this is a factor. Find me the rest of the zeros. Okay? If you have a factor, your synthetic division should give you a remainder of 0, and you can use your quotient to find the rest. Okay. Here's your homework. I want to give you some time to start in class. You have a long weekend. Please do not go all 3 days without looking at math, especially since we have a quiz on Wednesday. Okay? We will have time to answer a couple questions Tuesday. I'll tell you what's going to be on the quiz, and then we are learning new material on Tuesday that won't be on the quiz. 5 through 45 by 4s, that will go quick.
Depends on the problems.